So let us make it bigger. Yan, no? Hide natin. Plus, how did you find the activity on this note-taking on the double integration method? Did you find any difficulty, class, na okay lang ba sa inyo? Or ano, naka-encounter ba kayo ng mga difficulty in understanding the lesson? Hmm? Class, unsa may inyo nakasabot ba kayo, by the way? Nakasabot ba kayo sa activity? Nakasabot ba kayo sa topic?
Wala pa ko kayo kasabot sa topic, ma'am, kay dili pa po ko kayo master sa ng double integration.
Okay. How about the link that I advise you to go over? Nakita niyo yung mga link? Nakita niyo yung mga link?
Yes, ma'am.
Or okay. So we're going to discuss it now, but I hope that you have to take time on listening to those links because it will really help you on the understanding about the concept of the double integration method. So let me share with you the material. Okay, mag-share muna ako ng blank Class, medyo nagdugay-dugay ta kay kanina pa ako nagtatry na makakonect sa internet. Pero because all of us here in the faculty room are having the online classes, kaya medyo naghina ang internet natin. But by the way, will you please open first all your cameras for the documentation? Okay. Let me see all of you. Okay. Hinay good si internet class. Hinay talaga. How about Hana Concha? Hana Kyle, Tuble, Kate, Angkla, Obkia, Apolinares, Muñez. Will you please open all your cameras? Biliran. Akin nagre-record lang ko class. Sandali. Okay, thank you. So let us now have the topics. I will share with you the topic on the double integration. So, double integration method is before. So this topic class on the double integration method is no longer approximate. Hindi na approximate ne. But this time, we are going to have more on equation on deflection. Deflection equations, why? Because just in case we encounter indeterminate structures, we can easily uh, analyze the structure by using those additional equations that we're going to have, and those are the deflection equations as well as the angle of rotation equation. Ano ba yung angle of rotation? Let us have first a short review on the topic of deflection. Okay, do you still remember class? The deflection? Timanan niyo pa ang deflection natin? Ha? Do you still remember it, class, yung deflection natin? The theory of deflection? By the way, class, so can you hear me? Do you still remember the deflection? Naka-remember pa kayo na ating i-discuss? Okay, gamay. So we're going to discuss a little about it or review a little about it so that we can easily understand our topic because it is so important that we have the knowledge on the deflection. Ano ba yung deflection natin? I'm going to share with you blank form. Okay, can you see it, class? Makikita nyo? Makikita nyo yung blank na form natin? Okay,
Yes,
good.
ma'am.
So, okay, yan na. Ano tayo? Okay. Ayan. Let us have the, let's say, let us have a beam, no? Let's say this is the beam. So, latay beam. Let's say this beam is simply supported. Yan. Importante kini class, importante kini mga supports. Okay. If this beam is being loaded with a load P, let's say nag-load tayo ng P, take note since we are going to assume that this is an elastic analysis. No, kung tayo nasa elastic. So therefore, or elastic theory, kining beam na ni will deflect this way. Diba? Mo-deflect siya. So, ano na siya, no? So this will be the exaggerated lang the class. This will be the exaggerated form of your beam once it is loaded. Ani na siya? Such that let's say at this point C, let's say this is point A, this is point B, and this is point C. At this point C, nadiri na gud siya. Ani na inyong point C. Okay, so this is now your beam. So this is what we call the deflected beam. Kini na ang kanyang deflected beam. In such a way, let's say let's call it as Y. Ating let's call it as Y. Sometimes ang tawag natin diyan ay one. What is this symbol class sa Greek? What is this symbol sa Greek? Hmm? Kanara ba yung ating no. Anong symbol ni sa Greek class? If this is sigma, this is phi, this is alpha, this is theta, this is beta. Ano naman eh? Gamma. Okay. If this is gamma, what about this? Ha? Ano na eh? Omega. Correct. So therefore, let's say it's just a symbol. Ang importante, we know what is the notation. Di ba? Ano yung meaning? Let's say this is now the deflected beam. So if this is simply supported class, bantayan natin niya. If this is simply supported, there is the angle of rotation. Ani such that kini merong theta, kini yung point of tangency ano, meron siyang theta. Okay, there is the angle of rotation. So the deflection starts here at the support. No? Ang ating deflection angle basta siya ay simply supported whether it is hinge or roller. So naa tayo'y theta sa supports na ni. Now, if we have the fixed support, let's say magkaroon tayo ng beam that is fixed supported. Let's say this is a fixed supported beam. Okay. So, and let's say this is being loaded with P. So, what will happen? It will deflect this way, class. Aning dapita sa support, wala pa siyang deflection. Somewhere here. Na. Yan. So, So at this points naapa si angle of rotation dire. Aning dapita, point of tangency natin, zero ang slope. Sabihin, walang tayong angle of rotation sa support. Nakita nyo? Nakuha nyo, class? Ha? Basta fixed support, ang theta is zero. Di ba naalala nyo nung tayo mag-approximate analysis ng beam, yung at ano ng frame that is subjected to vertical loads? Do you still remember na let's say this is our loading, this is our W. Di ba somewhere here pa tayo, 0.1 L pa tayo magkakaroon ng zero moment. Diba? Naripa, ibig sabihin na ang magod tayo diri ay moment dire. So, at this point class, ang ating zero moment is somewhere here. No, not diri at zero moment, na a time moment ani. So, there at this point na pang angle of rotation. Dini walang angle of rotation sa support. So, yun ang ating bantayon nun ha. Okay, let's now go to our topic. So we are on the double integration. The term double itself means twice, ano? 'Di ba pag sinabi nating double, ibig sabihin duha ka beses tayong magpe-perform ng integration. Kaya nga double integration. So we are going to have now, para tayo makapag-integral, di ba, we need to have the variables, okay? So what we're going to integrate here is the moment, yung moment equation. Okay. So let us first know what we are going to understand after the discussion. First, we're going to have the boundary or continuity and symmetry conditions. Okay, yung boundary condition, continuity condition, and symmetry condition. Next is we are going to derive the elastic curve equation using singularity function. Why using singularity function? Because class, in your mechanics and in your strength of materials, this double integration method is already part of your the contents of the syllabus. However, we're going to explore it more this time by using the singularity function. So mag-perform din tayo class ng double integration. Ano lang kung makakaano na kayo, makaka-relate na kayo. Okay. So what is this elastic curve equation? So when we say elastic curve equation, yun ang tinatawag natin na deflection equation. No, yun ang deflection equation. Kasi when we say elastic curve, that is our deflection curve. Diba? Okay. And we are going, or we can determine already, the maximum displacement. Ano ba ng displacement? Actually, this is also the deflection. Pag sinabi nating displacement, nagkaroon na displacement siya, sabihin, nagkaroon ng deflection. Okay? So, you have encountered here the term elastic curve, which means deflection. Also the term displacement, which means also deflection. Okay? And also the location of the maximum displacement of the beam. Where is the maximum deflection of the beam? No? And the determination also of the rotation. Yung rotation, yung angle of rotation at the supports. Okay? So those are the things that we need to understand in dealing with this double integration method. Question? Naa ba may question? Ha? Any question regarding the objectives? Class, can you hear me? Are we still connected? Okay, good. So let's proceed pa. Okay. Let us now have the introduction. Structured deflections can occur from a variety of sources. No, kaya nag-start pa manggod tayo because the remaining topics or uh, the next topics will be dealing more on deflection and angle of rotation class. That would be part of the analysis. So the structure deflection can occur from a variety of sources such as loads, temperature, manufacturing errors, or settlement. Okay, so the structure must not be heavily deflected in order to be safe for its occupants. Hadlok ba ya class nang nakikita natin na nagkakaroon ng dakong deflection, ano? Class kung na mga cracks, yung mga heavy cracks, that is already a manifestation of settlement or deflection kung ano yung mga cracks. No? Let's say, di ba, pagkahuman ng linog, let's say na diri ang ating door or let's say sa gate na lang class, yun na lang ang gate. So let's say this is the ground surface. Then naatay diri ay gate. No, sa ating gate, let's say naatay din ay sirado sa gate. Okay. So before ng linog, okay pa na masarado pa natin yan. Pero after ng linog, mapapansin nyo, hindi na tayo makasirado. Mo-displace na siya. Misay, hindi na siya matupong. Na-observe nyo yon? Naka-observe kayo, di na siya magtupong. Kasi nagkaroon ng displacement aning soil. Kaya na tayo nagkaroon ng vibration, nagkaroon ng movement. Okay, that is settlement. Yung tinatawag natin na settlement. Okay? Kung nakakakita kayo ng mga cracks, nagkakaroon ng deflection ana. But then, that is not natural. Pero kung severe na gud siya, murag ma-worry tayo. Okay? So, more important, however, is that the reflections at the specified points in the structure must be calculated if it is to examine statically indeterminate structures. You see? So if we are already having indeterminate structures, this deflection equation is of great importance kasi hindi tayo makaka-analyze without using this additional equation. Kasi yan yung deflection equation will serve as an additional equation for you to determine other unknown. Diba? Kasagaran, let's say fixed supported. Let's say any class. Fixed supported. So, pila ang unknown natin dire class? Pila? Ha? Pila ang unknown? Sige nga, be. Kung fixed supported ang ating beam, pila ang unknown? Class? 3 ani? 3, another 3, di ba? Tama? Di ba?
Yes, ma'am.
There is a moment. Okay. There's a moment here. Horizontal and vertical reactions sa fix. Take note, ang ating equations of equilibrium, tulo lang ba ya? Di ba? Tulo lang. And we need 3 equations. And we need 6 equations in order to determine those 3 unknowns. So, ano ba ang target natin? We need to draw the shear and the moment diagram. And we cannot draw those diagrams without knowing the reactions. Am I right?
Yes,
Correct.
ma'am.
Di tayo makakadraw ng shear diagram unless otherwise kaibaw na tayo ng mga reactions. And how to determine those reactions? Imagine, there are 6. So, we need also 6 equations. So, naana tayo tulo ka equations sa equation of equilibrium, di ba tulo? We need additional 3. And those 3 equations, we can have the deflection equation, we can have the slope equation. Yung slope equation, yun ang tinatawag natin na angle of rotation. And then, another equation from the boundary conditions. Nakuha nyo? So, makaka-add pa tayo ng 3 more equations in order to determine the unknowns here. In order to determine the unknowns here, and after getting the unknowns, we can already draw the shear and the moment diagram or if not draw, let's say we can determine the shear diagram or the shear values or the maximum shear or the maximum moment sa beam. Mano mang kinahanglan yun? Because those values will be your design values. Yun na ang ating magiging design loads. No, pag naana kayo sa design, yun na ang ating hahanapin, yun na ang gagamitin natin in order to design your structure. So, kaya importante you can observe balik-balik ang shear moment diagram, balik-balik class. Because from those diagrams or kung hindi man diagrams, we can have it by the method of section, di ba? I-cut natin at section and then we're going to have the equation and then find the values of the shear and the moment at the point of cut portion. Okay? So, yun ang importante. Kaya tayo nagbabalik-balik because kinahala nating we need to know the reactions in order to determine the shear and the moment at the beams. Let's say beams tayo karon. Okay? So, this time, me continue. Continue natin. This time, we are going to know first the boundary and continuity conditions. You actually class, the one that I discussed a while ago is for boundary condition. Diba? Let's say, yung kanina, no? Let's say, if these are simple supports, this is the hinge and this is the roller. So let's say there's a load P here and this is the deflection. So what we are going to do, class, here is that we are going to cut this beam into section. Ikat natin ang beam and section. So, part of the procedure. We are going to evaluate the bending moment at a given section. Ibig sabihin, nagkakat tayo ng section to know the bending moment. But then take note that when we cut a section, nag-cut tayo in an unknown location. So, that would be your variable. Let's say X. No? So, you can also observe that there is a discontinuity of moment here. Nakuha nyo? From this segment, let's say segment AB, the moment of any segment, any section here is different from the moment here. Kasi meron tayong discontinuity because of this load P. So, ibig sabihin, ang ating equation diagram dire, let's say, ang ating moment equation ani, is different from the moment equation at segment BC. So therefore, we are going to consider both segments in order to have the moment diagrams. So let us try this. So recall that points of zero slope and zero displacement occur at the fixed point. Yung kanina, no? But take note, class, that sa lahat ng support, zero good ang displacement or zero good ang deflection. Walang deflection basta may support. No? Pero yung slope, may zero slope kung naa tayo ay fixed support. There is zero displacement occur at pin and roller. No, basta support na ay zero displacement. Okay, pero at those points na ay slope. Basta pin and roller or simple supports. So what we're going to do is to establish the x and the shear coordinate axis. Now, the x-axis must be parallel to the undeflected beam, yung ating x-axis, and its origin at the left side of the beam. So let's say any class, this is our beam, this is the left side, let's say this is uh, hinge support. So, pag nag-cut tayo ng section, this will be our X. No, gikan ani, that will be our X. So, from this cut portion, remember, di ba, ana ang ating moment? So, aning side na ni, ana ang direction ng inyong moment. Do not forget that. Kung shear pa ang ating i-consider, then this is downward. Here, this is upward. Nare-recall nyo ni class? Ha, basta tayo nag-cut ng section. Okay. Or tayo nag-cut ng beam, meron tayong section. Okay. So, if several discontinuous loads are present, establish coordinates that are valid for its region. Yun ang kanina, no? Yun ang kanina na tayo'y variable ani na x, naarin tayo ay dire. So, if this is x sub 1 hanggang dire, this is x sub 2 hanggang dire. Lagi ang origin ay ang left support. Left origin, no? Yung sa support sa left side. Okay. In all cases, the associated positive v-axis should be directed upward. Okay. Next, load for moment function. Yung load natin for each region in which there is an x coordinate, express the internal moment as a function of x, no? Of course, as a function of x. And we are going to assume that the moment acts in the positive direction when applying the equation. Actually, this is equation. Okay. And we are going to write the differential equation of the elastic curve. Okay. Kanang ating differential equation. Okay. So, yung ating moment equation is already the differential equation. Ani na siya. Okay? EI. Of course, class, when it is a deflection, there is always the value of EI. Hindi lang yan basta moment when it is already a differential equation. It is in terms of EI. Ano ba yung EI? Ano ba yung EI class? Ha? May I know. Ano ba yung E and I? By the way. Okay? Yes, this is modulus the modulus of elasticity, and I is the moment of inertia. So this must be part of the parameters. No, hindi yan basta moment na kini, this is the equation, moment equation once we cut it into section. But then, if we're going to have now the slope and elastic curve equation, we're going to consider that moment in terms of EI. So, mahina po ani is that is M over EI. No, kaya siya ay nagkaroon ng EI dito. M over EI. Okay. So, we are going to evaluate the constants of integration. Di ba? Sa integration, lagi tayo may constant. Using these boundary conditions. No, di ba na tayo, say, first integration, we have plus C sub 1, di ba? C sub 1, then we have C sub 2x, C sub 1x plus C sub 2. Mao naman good, na tayo laging constant of integration. But then, we're going to use this boundary condition such that when x is 0, ano ba yung x? That is the distance from the left support. Ang y natin is 0. Ano ang y na ni? This is the deflection. Excuse me. This is the deflection, no? We are going to represent our deflection as y. What do you mean by this? At the support. At the support, kasi sa x equals 0, there is a support. Deflection is 0. Once the integration constants are determined and substituted back into the slope and deflection equation. So, ano ang gagawin natin? I-establish natin si slope and deflection equation from the moment equation. Let's say, first, natay moment equation. Second, natay slope equation. That is the first integration. And third is the deflection equation. That is the second integration of the differential equation. Okay? Yun. So, na tayo yung moment equation. Then, express natin yon sa differential equation in terms of EI. No, EI d squared V over dx squared. And then, we're going to have the first integration sa slope equation. And then, we're going to have the deflection equation that would be the second integration, no? Or another integration of the slope equation. Okay. Kaya nga sinabi natin na double integration. So, let us have an example. Example tayo ha. Let's say this is a simply supported floor joist, which is subjected to a uniform design loading of 4 kilonewton per meter. Okay, so assume natin that this load is a dead load, no? Ano ang kanyang weight. So determine the maximum deflection of the joist. EI is constant. So kung EI is constant, so we are just going to have it in terms of EI. Okay? Pero if EI is given, we are going to substitute the value in our equation. Okay. So this is how many, what is the span? The span is from the figure, this is 10 meters na tani, 10 meters ba? Okay. So we're going to have now the cut section. I-cut natin eh. Ika-cut natin siya. Part of the solution, ani. Then yung cut portion natin, kuhain natin ang free body diagram. Okay? So you can see na tayo'y variable x from the left support, kanang ating x. And then we have now the moment at x. May moment tayo kasi wala naman diyang connection. Wala naman diyang pin or a hinge connection. So there is a moment here. There is the shear here. Downwards yan, no? So, okay. So, from the free body diagram, we have, kuhain natin ng equation ni moment, no? We have, let's say, summation of moment at point x is equal to 0. Anak class, mag-start tayo, ani, kasi dire, inihatag na niya si moment eh. Let us start from the very basic. We have to know the value of AY. So, what is the value of AY? If this is 4 times 10, di ba 40 divided by 2? So, we have AY is equal to 20 kilonewton. Is it right? Correct, class? Okay. So, nana tayo AY. So, in your equation or in your solution, you have to show the value of the reactions. Yan ang first and foremost na inyong kukuhain. Next class is, after getting the reaction, i-cut na sa section. Then, let's say summation of moment at point x is equal to 0. So, let's say we have AY times x, di ba? AY times x, upward na minus 4 times x, di ba? 4x times x over 2, correct? Okay, minus mx is equal to 0. So therefore, what would be our equation? Ang ating AY is 20. So therefore, we have mx is equal to 20x minus 4 over 2 is 2, 2x squared. So, ano na siya, class? Kaya tayo meron 20x minus 2x squared. Nakuha nyo? Kaya meron tayo ani.
Yes,
Yan.
ma'am.
Okay, yan ha. Yan ang solution natin. And then after that, we are going to express it into a differential equation. Magbubutang na tayo ng EI. So, di ba we have EI, d squared V over dx squared, correct? Pwede rin namang to make it easier, class, ang iban ay, let's say, EIY double prime. Ang slope equation is EIY prime at ang ating deflection equation is EIY. Okay nyo? So let's say ang ating differential equation is EI double prime para mas simple, ano? Is equal to 20x minus 2x squared. Kukopyahin lang natin yan. Kukopyahin nyo lang ang inyong moment equation. So, this is now our first equation. no, differential equation. Then, first integration. First integration, let's say EIY prime. Okay. Is equal to, di ba? 20x over 2 is 10x squared. Di ba? Mas squared na, ano? So, that is 10x squared. So, minus ni 2x squared. So, maging 2x cubed over 3. Kaya nga, 2 over 3 is 0.667 x cubed. Plus C1. Pwede natin ibutang na C1x. Pwede natin yan. Plus C1x. Okay? C1x. That is the first constant of integration. This is our second equation. Let's say this is the first equation. This is the second equation. Class, nakasabot ba mo? Okay. So let's say this is our third equation. EIY, pwede yan, is equal to the slope equation. No? I-integrate uli natin 10x squared, it becomes 10x cubed over 3. Correct? 10 over 3 is 3.333x cubed. Minus, so integrate natin 0.667x cubed. That is 0.667 over 4 times x to the fourth. Diba? Plus C1x plus C2. This is now the second constant of integration. Correct? Correct. Is it correct?
Yes, ma'am.
Okay, good. So therefore, naana tayo ay duha na integration sa ating differential equation. So kini karon ang ating i-evaluate. Okay. Using the boundary condition. Okay. So at x is equal to 0, di ba ang deflection ay 0? Tanawan nyo ani. Kung naa tayo'y, ang x ay 0, so naa tayo sa support. Ang naabay ay support, dire. So, ibig sabihin, ang ating y is equal to 0 at x is equal to 0. Nakuha nyo? At x is equal to 0. Now, another. At x is equal to 10. Kung nadire, still y is equal to 0. Kasi support din siya. Ang x nidaga na ng 10. So, these are boundary conditions, class. Makonsider natin siya na boundary condition. Another, at x is equal to 0, y prime is equal to 0. No, no. No, it's not 0. Hindi pa yes. There is y prime. There is the value of y prime at x is equal to 0. There is a theta here because it is a simple support na ay angle of rotation sa support. So at x is equal to 0, y prime is equal to theta. Okay, there is a slope there. Ating hanapin karon. So go back tayo ani. So therefore here class, ginamit natin kining third equation such that we substitute here na ang kung ang x ay 0, y is 0. So, ibig sabihin, mas 0 na eh. Kung kini ay 0, x ba ay 0, kini ay 0, kini ay 0. So, makuha natin ang c sub 2, which is equal to 0. Nakuha nyo? If we are going to use this, yan. Okay, good. Kasi this right side is 0. Kasi ang ating deflection ay 0. Na tayo x ani which is 0, mas 0 ni. Export is 0, mas 0. Na tayo x ani 0. So C2 equals 0. So na tayo ay relationship na pod. Another equation yan. And another, at x is equal to 10. 'Di ba? Ang y is 0 or v is 0. Ang b niya dire is y, ano? Deflection. So, 'di ba 0? So that makukuha natin si c sub 1. No, using the same equation. Kung ang ating, 'di ba, may equation tayo din ng dire 3.33x cubed minus 0.1667x to the fourth plus C1x. No? Kini ay 0. Pero kung ating i-substitute ang 5 ani sa x, kini ay x equals 5. So, ang y natin sa right side ay 0, makukuha ninyo ang c sub 2. Makukuha nyo ang c sub 1. Nakuha nyo, class? No. Di ba? Ayan. And from that, ano siya, class, sa equation? Ano siya? Nire-write siya, ani? Kini 0. Kasi support. Kini ating C sub 2, di ba? C sub 2 is 0. So, ano is 0? So, if this is 0, x cubed, x to the fourth x, di ba makuha natin si value ng x? Note that this, okay, di ba nakuha natin si value ng x? Dire. Okay? Kasi ang ating uh, y is 0. Ang ating deflection ay 0 at x is equal to 10. Okay. Another class. Another is, kini class, hanapin natin si maximum. Paano natin, di ba, ang problem is to get the maximum deflection. Take note na kining ating beam is simply supported. Simply supported, uniformly distributed ang load, symmetrical. Let's say, ating beam. So, na tayo ay simple support, Obviously, symmetrical ang ating deflection. Nakuha nyo, class? Such that at the center, naandyan ang maximum deflection. Am I correct? Yan. Take note sa maximum deflection, let's say sa maximum y, no? Ang kanyang slope diri ay 0. Diba? Kung tayo may sag, ang sa maximum point, 0 gud siya. 0 ang slope. Masiro ang slope, at this point. Diba may slope tayo, this is theta. Pero kung kining point natin, point of tangency here, 0 gud siya. Okay, sa maximum point. So therefore, with that, makakakuha tayo ng yung sinasabi natin na symmetrical condition. No? Such that at x is equal to 5. Diba? Ang center ay 5. Okay, class, Okay. Ating y prime is 0 at x equals 5. Nakasabot kayo, ani? At x equals 5, ang y prime is 0. Ano ba ring y prime? It is the angle of rotation. Ani? The second equation. Kining second equation na tayo y prime. Nakuha nyo? Kanang dvdx. dvdx. Now, yun ang ating y prime. So, we have an equation here. Kung isa-set natin siya sa 0, we know already the value of C1. Diba? Nakakuha naman tayo ng C1, ani? Substituting the value of C1 here with x equals 5. No, x na with x equals 5. So, makukuha niyo ang value na x. And upon calculation, this is the obtained value of x. 521 class. So, ano lang, balik class sa equation. Ang ating equation, i-rewrite natin, no? Let's say, E, I, Y prime is equal to, we have here, 10x squared minus 0.6667x cubed plus C1x. That is our first integration, di ba? That is our first integration. Plus C1 pa siya, wala siyang x, plus C1. Plus C1, sorry. Sayop ang ating plus C1 siya. Plus C1, di ba? C1 pa lang. Okay. And our C1 class is equal to, anong ating C1? C1 is equal to, nakuha natin din na we have negative 166.7. Yan ang value ng ating C1. Take note of that. Now, if we have y, kung kini ay 0, kasi 0 nga sa x equals 5. Kung 5 siya, kini ay 5. Di ba makukuha niyo ang C1 is this one. Then, okay, 5, 5, y prime is 0. C1 is 0. Ang maximum deflection natin, okay, at x equals 5. Sandali class ha. Ano naman ako? Okay. At x equals 5. No. Hindi pala. At x is equal to 5, ang ating maximum deflection at x, okay ha. At x equals 5, ang ating slope ay 0. Ang ating slope ay 0 at x is equal to 5. Okay. Now, what would be our, nakatabang good siya sa pagkuha rin natin ng C1. What would be our maximum deflection? Ang maximum deflection is at x is equal to 5. Yun pala. Ang ating maximum deflection is at x is equal to 5 kasi naandyan ang zero slope. So at x is equal to 5, let's say hindi siya 0, ani. Kukuhain natin ang value ng ating deflection at x equals 5. What is the value of? Andin natin. Kaya, ani class? At x is equal to 5, the value of y is maximum. Yan. Maximum ang value ng ating y at x equals 5. See? That is the anisia. No? X equals 5. So, what is the deflection equation? EIY is equal to, kini ba yung ating deflection equation? 3.33x cubed, no? 3.33x cubed plus or minus 0.1667x to the fourth. And minus 0.1667x to the fourth. Okay? What is next? Plus C1x, di ba? Plus C1x plus C2. Di ba? Maong ating equation, second integration, the third equation. Ang C2 is 0. Ang C1 is obtained already, which is negative 166.7. Kini class, kining ating C1 is negative 166.7. At ang ating x is equal to 5. So this is also equal to 5. 5 to the fourth. This is 5 cubed. So makukuha natin si EI si y in terms of EI. So y is equal to, okay, kining value na ni divided by EI. Okay, nakasabot kayo? Mao ang pinaka-concept plus yun ang concept ng double integration. No? Kung naamoy gitanaw na link sa YouTube, mas masabot na ninyo this time. Now, ang tawag plus sa second equation is elastic curve. Ano? Kini ang ating not elastic curve, slope equation. First is moment equation. Ano lang bantayan nyo klasa? Ang first ay moment equation. Moment equation. Kukuhain natin si moment equation. After getting the moment equation, establish natin si differential equation. No, differential equation. Okay? Differential equation natin is, let's say, EIY double prime. Yan. And then second is the slope equation. Slope equation, let's say this is EIY prime. And then let's say we have the deflection equation. Deflection equation, let's say this is EIY. So kining Y nani is the deflection, kining Y prime nani is the slope or the angle of rotation, and this is your moment differential equation natin. Okay? So that is how you're going to analyze the beam using the double integration method. Ani class, ano? Kini, we can express it in this way, d squared v over dx squared, man naman sa ating differential, di ba? Then dv dx, and then your v, third equation. Now, first is the moment, mo. Then we have the constant of integration, c sub 1. Then we have the another constant of integration, c sub 2. Nari class. Okay, class. So, any question? Any? Yes, go. Mm. So it depends upon the boundary condition. Doon natin hahanapin. Okay? So, we will go over with that. Siguro makita natin sa iba natin. Marami tayong examples. Okay. So, nadire ang maximum slope and displacement occur at x equals L. So, probably this is cantilever siguro ano siya. Makita naman natin. Pag kining sample na rin, makita ko is cantilever na rin. Sabihin, at this point, wala naman din support, ladder and maximum deflection ani. Okay. Makikita natin class dun for it. Let's say, let us have the ani. This is an example. Aking lang alisin yung aking mga sinuwat-suwat. Dire, gamit ko na yung space na yun. And this is another example, class, such that we are having fixed support at one end. Good afternoon. Sandali lang, class, ha. Marami lang ako, sir, nagka-text. Good afternoon, ma'am. Walay content ng learning material ang naa sa class namo, ma'am. Ang dilisag namo mag-free. Thank you. Okay. Wait lang, fasa. Kaya atin lang na silang i-reply. Kasi nahirapan ako talaga kanina sa internet. Baka yung pakapag-send ko ng learning material sa kanila, one successfully sent. Ano for a learning materials. Wait lang class for a while lang. For a while. Okay.
Luca.
CPC 0648. Wala raw learning material. Kasi nga. Sa learning material. Bunga naman. Okay, link lang naman yun. Link. Na naman. Masalaw sila nakapo. Please open the link. Paano nila na-off then? Please open the link. Open the given link. The given link. Na-open ko. Na-open ko. Na-open ko. Just now. Okay. Okay, continue na ta. Hindi lang sila nakasabot siguro ani. Link na niya. Okay, go, go. Nasa na ta? Okay, class. Continue ta ha. Okay, so therefore, let us now have the second example. It is a cantilever beam. Di ba? Cantilever na. Ay,
Yawa.